that I have explained you how to solve the problems based on the simple pendulum, because see, basically it is very, very important while you're solving by energy method. You know that kinetic energy is equal to 1 half m into h dot square, right? Secondly, potential energy is of two types, one half kx square. This is called the strain energy or internal potential energy. And the thirdly is potential energy is equal to mgh. This is called the gravitational potential energy due to the datum position or the datum height h, which is considered from the CG, right? It is considered from the CG. So basically, as far as the pendulum is concerned, I have explained you that we have to consider the potential energy mgh and the kinetic energy 1 half mx square for this a simple pendulum which is suspended vertically at the point O. So that is why that basic problem was very, very important. Okay. Now we'll solve this problem. Now what you can see that again there's a, you can see a simple pendulum, right? The simple pendulum is suspended at point O. It is having a length L. It is having a stiff spring connected at a distance A. Now you can see that this particular point, and this O point, let me call this as a point 1 for your understanding. Okay. Let me call this as a point 1. Which point? This point. So the spring is connected at point 1 and the distance between the point O and 1, they have given it as a. Is it okay? Now, what is the first step we have to do? We have to give a mass m, a small displacement. Means what? Let us say that this mass m or a pendulum is given a small angular displacement theta. So what will happen? This pendulum will come at this position, let us say theta. Okay, so you know that. So this becomes h. Okay, so this becomes h, right? This is a height h and this is a theta. Okay, so if I draw this vertical and horizontal line, then this will be also theta. This is L cos theta. This is L sin theta. And then this h is equal to L minus L cos theta. Therefore, h is equal to L into 1 minus cos theta. So this is the h what we are getting. So from this h, you can calculate the potential energy. And now, what you can understand from this position, what you can understand that this one point will go to this point number 2. This one point will go to this point number 2. So let us say that the distance between the point 1 and 2 is x. The distance between the point 1 and 2 is this. Means what? This 1 to 2 distance is equal to x, right? So what you can say that this particular point 1 moves from one point to the 2 point by a distance x. So what do you mean by this? That this displacement of the spring is x, which is equal to the distance 1 to 2, right? So what is the displacement of spring? Means what? The spring will get extended, the spring will get elongated by x, means what? The distance between the 1 to 2. I hope it is clear to all of you. This is what is happening. Okay, so let's start. So let the mass m is displaced by small angle theta, let x be the displacement in the spring. So you are getting this figure. Okay, now this figure already I have explained you now currently. So this is again, I have redrawn over here. So you can see that x is the displacement of the spring and theta is the angular displacement of the mass. So you can see that this is L cos theta. So h is equal to L into 1 minus cos theta. So this is always you have to remember. So what triangle you are getting? You are getting this triangle. So let me draw this triangle here. Okay, let me draw this triangle here. So let me call this as a point 1. Let me call this as a point 2. And let me call this as a point O. Let me call this as a triangle. Let me call this as a theta. And let me call this as a x, and this is nothing but a height. So tell me what you are getting from this. So what is x? Anybody? So from this triangle, I am getting x is equal to what? X is equal to a into, yes,
theta.
Theta. Basically, it is a into sine theta, but theta is very, very small. So sine theta is equal to theta. So x is equal to a into theta. This is the equation I am getting. Okay, right? And then you know that this is theta. Okay, this is L cos theta, then there will be L sin theta, this distance. Okay, this distance will be L cos theta, right? So h is equal to L into 1 minus cos theta. So this is how you have to start the problems. Okay, so I have started. Now next, total energy of a system. Now I think we have solved a number of problems. So I think you are clear with my the method which we are trying to solve, that is applying the energy method. So first of all, total energy is equal to constant. So kinetic energy of mass m, potential energy of mass m, and potential energy of the spring. Okay. So I just want the answer from your side. What is kinetic energy of mass m? Anybody? Kinetic energy of mass m, rotational or translational? First of all, you have to understand this. Now we have already solved a problem on the we have solved on already a problem on the simple pendulum. Okay, so kinetic energy of mass and translational or rotational in this case. One of, yes, anybody, one of I into theta square. So kinetic energy of mass rotational, na? Yeah, rotational. Plus potential energy of mass m, mg into h. Plus c, potential energy of mass m, because your height is h is changing. Initially, your height was at this position, and it went to this position. Means what? Let us say this is a g point. Let us say this is a g point. So this is g dash. So this total distance is nothing but the height h. So that is changing. And let us say this is a datum position. So your h is changing with respect to datum position. Means what? Potential energy, the stored is nothing but a gravitational potential energy. So that is why it is very, very important. Okay. So let us take this all point. So 1 of I theta square kinetic energy of mass rotational. So this case is only for the pendulum. Try to remember that. For pendulum, we are having mgh plus 1 of I theta square. And now the spring is connected. The spring is having an internal potential energy 1 of k into x square. Okay, is equal to constant. So I think it is clear to all of you what is the next step. So 1 of I is nothing but, now you know that for a simple pendulum, not for a compound pendulum, for a simple pendulum, I is equal to ml square. You know that I is equal to ml square by 12. I is equal to ml square by 12 for a slender bar. Okay, but here it is not a slender bar, it is a simple pendulum, right? So I is equal to ml square theta dot square plus mgh L1 minus cos theta, because h is equal to L into 1 minus cos theta, and plus 1 of k, x is equal to a into theta. So x square is equal to a square theta, right? So these all terms I have. So finally you can see that I have converted x into the one parameter, that is a theta, as I said, as I have done in our last problem. So differentiating with respect to time, okay? So 1 half ml square. Now you know that derivative of 2 theta dot square, 2 theta dot into theta double dot. Remember it if you are not understanding. Derivative of mgl, derivative of mgl 0. You know na, mgl minus mgl cos theta means what? This term is what? By opening the brackets, mg into l into 1 minus mgl into cos theta. So mgl will give you the 0 differentiation, minus sign will become plus, because cos theta derivative is nothing but the minus sin theta, and derivative of theta is equal to theta dot. So sin theta into theta dot plus 1 up k square, derivative of theta square is equal to 2 theta into theta dot. Okay. So this is how I did it. And you can see that 1 half and 2 get cancelled, and theta dot gets cancelled, and 2 gets cancelled. Okay. So let's finally what I get, ml square theta double dot plus mgl theta plus k square. So you know that we have to compare this with the simple harmonic motion. So theta double dot plus mgl plus k square plus ml square theta is equal to 0. So finally comparing with the standard equation, what is standard equation? Theta double dot plus omega n square theta plus, sorry, is equal to 0. Okay. So from this I am getting omega n square is equal to mgl plus k square upon ml square. And finally you are getting a Fn is equal to 1 upon 2 pi mgl plus k square plus ml square. Okay. Now message me, have you understand how to solve the problems of a simple pendulum? Okay. So in the last problem, I have explained you how to solve the same problem by a D'Alembert's principle. So now here I will not explain it again. You can try on your own. You can solve the same problem by the D'Alembert's principle. So whenever you are solving by the D'Alembert's principle, so this is your homework. Solve this problem by the D'Alembert's principle. So there are two restoring torques. Okay, there are two restoring torques. One is I theta double dot inner torque plus mgl sine theta. Okay, this is what? External torque, right? So these are the two torques which are acting, which you have to consider while you are solving this problem by the D'Alembert's principle. Okay, and plus again the spring is there. So whatever the spring is there, that you have to consider also. Okay, so you solve this problem. I hope it is clear to you. Okay. Chalo, next. So I'll move on to the next block. Now we'll slightly move on to the next type of problem. Let us say a problem based on a fluid mechanics. Okay, fluid mechanics. Okay, till now we have solved a problem based on the mechanics only, like simple spin mass system, pulley system. Okay, slender bar system. Now we'll move on to the fluid mechanics, because in fluid, in water, or maybe in a liquid, there is a vibration, right? So I hope you understand. A liquid can also vibrate. A fluid can also vibrate. There is a vibration in the fluid medium. So we have to solve the examples to find out the natural frequency for the same, right? So let us solve. Okay. So a simple YouTube manometer, okay, you can see this. A simple YouTube manometer with liquid is shown in the figure. Calculate the frequency of resulting motion if minimum length of the YouTube manometer is L. Okay. So first of all, you forget this figure. You forget this figure. This is a figure after the displacement. So consider this is a figure given to you. Okay. Forget about this. So what they have given? Okay, you can see this line is called the static condition, static equilibrium position. Means what? There is no any movement, there is no any motion in the liquid. The liquid is quiet, liquid is standstill. Okay, is it clear? And now what is a L? L is nothing but this total length. This total length is nothing but the L. So what is L? Is total length, that is a length of the liquid column. So, for example, the total length from this point to this point, from this point to this point, let us say point number 1 and point number 2, this total length is nothing but the L they have given. So they have given you this much only, right? Okay. Now, how will you solve such type of problems? Okay. So to solve the such type of problems, first of all, you have to give some displacement. You have to give some displacement, right? So how will you give the displacement? Again, same. Let x be the I will start. Let x be the initial displacement. X be the initial displacement. Let's say it is in the downward direction. So let us say that you are applying an initial displacement x at the first column, or you can say at this is the first column. Let us say this is the second column, or you can call it the first column of a tube, or second first tube or second tube. You can call it so. So in one tube, you are providing a x as a small displacement, right? So when you are providing a x as a small displacement in the one tube, what will happen? You can see that in this figure, let us say this is the equilibrium line. This is, let us say, equilibrium line. Okay. So the amount of liquid which is, you can say, which will the amount of x which will move in a downward direction, same amount x will be raised in an upward direction, right? So what I mean to say is that in such type of problem, if x is the displacement given in a downward direction, so let us say this much is the displacement in the downward direction. So this much, that is the x, will be the displacement in the upward direction. Means x is the amount by which the liquid is raised in the U tube. And in which tube? In this tube number 2. And in tube number 1, x is the amount by which the liquid is lowered in the first tube. Okay. So now tell me what will be the total amount of displaced fluid. Okay. So what will be the total displaced fluid? Anybody?
2x.
What will be the total displaced fluid? Considering both the tubes. You can see here, I have mentioned here. What is the total displaced fluid?
2x.
2x, right? So x lowered in the first column, x raised in the second column, second tube, sorry. So total is nothing but the x. Okay. So this is the equilibrium position diagram which is given to you. This is the displaced position diagram which you have to draw. Try to draw these both the diagrams on a same parallel page. Okay, parallel to each other on a same page, right? So that this equilibrium line you can show a single line. Clear? Okay. Now how to solve? Now basically guys, you have to use some fluid mechanics concept over here. Why? Because they haven't given you anything. The data is insufficient. So you have to assume some data based on your past knowledge, right? So what is that data? Let us say that L is the length of the, let us say L is the length of, minimum length of the manometer. This is a simple manometer, na? So L is nothing but a length. Okay. Length means what? The the length, you can say the minimum length of the manometer, right? Let us assume that rho. What is rho? What is rho? Mass density of liquid. Rho is mass density of liquid. Mass density of liquid, right? And then we'll assume A as the cross-sectional area of the tube. A as the cross-sectional area of the tube. Okay. So guys, this particular you can say terms have not been given in a problem. This is by your experience, past experience or past knowledge you can consider. Otherwise, how will you solve the problem? Na? So what I have considered, L is given. L is the minimum length of the U-tube manometer. Rho is nothing but the mass density of the liquid, kg per meter cube, sorry, and A is the cross-sectional area of the tube. Okay. So basically, I'll move on to the next point. Now, if let us say that if L is the length, rho is the mass density, and A is the area, can anybody tell me what is mass of the liquid M? So mass of the liquid Mass of the liquid, small m. Can anybody tell me how do you calculate the mass of the liquid? This is a basic formula. How will you calculate mass of the liquid m? Because we have to find out the kinetic energy. See, when the liquid will start vibrating, will have a motion. So there will be the kinetic energy. So kinetic energy of a liquid is nothing but a 1 of mx dot square, right? Because x is the displacement you are providing. So x dot is the velocity. So first of all, you have to find out the m. M is not given in this case. You cannot keep it as a m. So tell me, how do you calculate m? Yes, how
Rho
do you
into
calculate
volume.
the m? Mass rho into volume, right? So rho into volume is correct. So rho into what is volume? Area into length, right? Area into length. You know, na, this is kg meter cube into meter square into meter. Meter square get cancelled, so you will get mass into the kg. Okay. So first point I have got is nothing but the m is equal to rho into L. This is nothing but the mass of the liquid. This is nothing but the mass of the liquid. Now anybody from your side, I want to answer one thing. Now if I want to calculate the mass of the displaced fluid, only the fluid which is displaced, total, okay, this is the total fluid. What is the total fluid? L. So what is the mass of the total fluid? Rho A into L. Now I just want to calculate the mass of the displaced fluid. So can anybody tell me what is the mass of the displaced fluid? What is the amount of fluid displaced?
Rho A
Yes,
to S.
exactly. Rho A into 2x. This 2x is equal to L, or 2x is equal to amount of displaced fluid. If you are able to understand this, you can solve any type of problem based on this. So rho A into 2x is nothing but the mass of the displaced fluid. Chalo guys. Now you have understand this. So it is very easy to understand rest. So now rest, what you'll do, you'll find the kinetic energy 1 of m into x dot square. You know what is m, and potential energy. Now anybody from your side, okay, we'll first finish off this part. So here I have mentioned what I have explained you. X be the displacement given to the liquid in the one tube of manometer. L is the minimum length of the manometer. Okay. Rho is the mass of the density. Okay. Cross sectional area. So mass of the liquid rho into volume L. Rho into 2x mass of the displaced fluid. So according to the energy method, total energy equal to constant. So kinetic energy plus potential energy equal to constant. Okay. Now what is kinetic energy? 1 of mx dot square. But what is m? Rho Al x dot square. So kinetic energy is equal to rho L x dot square. Okay. Okay, now this is clear. Kinetic energy is clear to you. Okay, so kinetic energy is clear to you. What is kinetic energy? I have got kinetic energy is equal to 1 of m is nothing but a rho Al into x dot square. Now I want to answer from your side. How will you calculate the potential energy? Yes. How will you calculate the potential energy for this in this case? Yes, anybody? If you can guess out, or if you can apply the logic here. Mechanical vibration is completely based on the logic. Yes, potential energy. In this case, potential energy will be a gravitational potential energy or a strain energy, first of all. Gravitational
Gravitational
potential
potential
energy,
energy.
right? Gravitational potential energy, right? Very right. So it is mgh. It is mgh. Okay. Now it is mgh. Now let us see what is mg and what is h. Now what is m? First of all, now basically, guys, try to understand that you have a two tube. This is a first tube. This is a two tube. Okay. In both the tubes, let us say this is the x. X is the amount of fluid displaced. Okay. So what? Where will be the CG here? What will be the CG? CG will be at x by 2. Okay. So this is nothing but a G point. Okay. The potential energy, you know now. Let us say this is, if you take an example of a dam, the liquid stored inside the dam, let us say, okay, it is having a potential energy. Okay, and it is nothing but the mgh, and h is nothing but the height which is considered as the CG. Okay, it is considered the CG. So similarly here also, first of all, let us understand CG. So for this column, what will be the CG? X by 2. And what will be the CG for this column? X by 2. Because X in this column, X is the total amount of fluid lowered or raised. So what will be the CG? CG will be at center, that is X by 2. Okay. So this is the first point you have to understand. Now you understand the CG. So how will we find out P? So potential energy is equal to mgh, that is equal to, first of all, I will consider for the, you can solve the problem for both the column also, but it will make us easy to take one by one tube. Okay, so mgh for tube number 1, mass, what is mass? Rho A into x. Now here, guys, try to understand that you cannot take rho A into L because you are finding a potential energy. So potential energy is only for the displaced fluid. The fluid which is displaced and stored at some height means what? There is a extreme energy, and at extreme point or at extreme end, potential energy is maximum. At minimum end, mean end, kinetic energy is maximum. So potential energy is stored at the extreme end when it is displaced. So that is mass you have to consider rho A into x into g, and what is x? H by 2. Plus again rho A into x into g and x by 2. So this is for the second tube, this is for the first tube. I hope it is clear to you. I hope it is clear to you. Okay. So similarly, you can see I have calculated here. So potential energy of a fluid is displaced fluid, mgh. That is rho ax g into h by 2 for tube 1. Rho ax g into means what? This is m, this is g, and this is h. So finally, you are getting half plus half equal to 1. So you are getting rho a gx into h. So potential energy is nothing but a rho a x square into g. Okay. So now we have got potential energy. Now what is the next step? Anybody? What is the next step? The next step is very simple. Okay. So total energy is equal to constant. What is total energy? That is equal to kinetic energy plus potential energy is equal to constant. Right? So what is kinetic energy here? What is kinetic energy here? What is kinetic energy? I've already solved now. 1 half rho AL. This is kinetic energy x dot square plus what is potential energy? Rho A g into x square is equal to c, right? So differentiate, how will you differentiate? 1 half rho a into L, this is constant, 2x dot into x double dot plus rho a g constant into 2x into E is equal to 0. So 2 will get cancelled, x dot will get cancelled, and the remaining answer will be here. I think rho A will get cancelled, rho A will get cancelled. So answer is L into x double dot plus 2 into gx is equal to 0. So x double dot plus 2g upon L into x is equal to 0. So comparing with the standard equation, you are getting omega n is equal to square root of 2g upon L. That is radian per second. Now guys, message me, have you understand the problem or any doubt in this problem? So I can move on to the next problem. Yes. So today we will solve number of problems and we will finish off this model. I will try to finish off this model. Or if needed, I can take one more lecture on Friday. Otherwise on Friday I will start model number 4. So please message me, have you understand, is there any doubt in this problem? That is, sir, there is a doubt in this problem, so and so. Yes. Is it clear? Or else I will move on to the next problem. Message me, is it clear or not to you? Hello? Hello? Anybody? Okay. I hope it is clear to all of you. Okay. Now we will solve the next problem. Same again, I will take an example of a V-tube manometer. Means what? The U-tube manometer. Instead of U-tube manometer, here we will take an U-tube manometer which is at an angle alpha or V-tube manometer. Okay. Now you can see this. Okay. Just a second. I will. Maximize this. Okay, you can see. So what they have given, a V-tube manometer having a liquid column has both ends open to the atmosphere. Find the omega n of a oscillation of a liquid column when tube is slightly displaced. Now in this figure it is very important. Now you can say that this is a vertical line. Okay, this is a vertical line, and from vertical line you can say this is the center line of this tube. This is the center line of this tube. So the angle between this vertical line and the center line of the tube is nothing but the alpha, and this angle they have given alpha. Okay. So now instead of this a U-tube manometer, they have taken a V-tube manometer, and the angle from the center is alpha. Okay. And now they are saying that find out the natural frequency. So I think the process which I have used in the last problem or the logic which I have applied, the logic will not change only because of that angle. Some geometry will change. There is some change in the geometry. Okay. So anybody, tell me what is the first step? What is the first step you have to do in this case? Anybody from your side? You have to displace the fluid. So let us say that the fluid is displaced through vertical displacement x from the mean position. So what is the mean position? This is the mean position. Okay. So from mean position, I am giving a x as a vertical displacement. Okay, so I'm saying that let fluid is displaced through a vertical displacement x from the mean position. Now, guys, you have to understand that the orientation is angular. Orientation is angular, and if the fluid is like this in an angular position from this, okay, and you are giving of x as a vertical displacement, so the actual displacement will be this much. The actual displacement will be this much, right? This is the actual displacement. Okay, you are giving a vertical displacement x, but this v tube is inclined. So what will be the actual displacement? This will be, let us say, actual displacement. So let us say that this distance, that is actual displacement, is y. Okay, I am explaining you again with this figure. You can see this figure. Okay, you can see this figure. From this point, you can see this is a vertical distance. Okay, this is a vertical distance x, you are giving a displacement, but what is the actual distance, or you can see what is the actual displacement? This is the actual displacement. What is the actual displacement? Let us say it is a y. So now you can see that if y is the actual displacement in one tube, you can see that in another tube y will be the actual displacement, which is what, which is raised. Okay, so this is the difference between the two problems here. Again, you are applying the same x as a displacement vertically, but since this u2 is not vertical, this manometer is not vertical, it is an incline, so you have to consider y as the actual length of the fluid column displaced. So I hope it is clear to all of you. I will just increase this. Okay, is it clear, everybody? Is it clear, all of you? This figure is clear. Now you can see this figure. Okay, now you have to just see the you can see the geometry of this figure. Now in this figure, let me solve. You can see that this distance, total distance, this is nothing but the x raised, lowered. So let us say this is nothing but the y actual, and this is nothing but the y. Now you know that this is the vertical line. The angle between the vertical line is nothing but the alpha. So let us say this is the point, mean position point. Okay. See, I am taking it again. I will change the color pen so it will be easy for you. You can see this is a mean line, na? Very, very important. This is a mean line. So if you draw a vertical line from this mean line, if you draw a vertical line from this mean line, see, okay. Now this vertical line which I am drawing, you can see which I have drawn here, this vertical line. So you'll get this intersection point here. Okay. Now this vertical line and this vertical line, they are parallel to each other. So what I mean to say is that, let us say this is the center line of the tube. So this angle will be the alpha, and this angle will be also the alpha. Okay. So just for simplification, I have considered this line. Is it clear now? The angle between this vertical line and this is nothing but alpha. So if I consider the vertical line here at this particular point, okay, so what you will get at this particular point, this angle you will get alpha, and this angle you will get alpha. So is it clear how I have taken this angle alpha and how I have taken this angle alpha? Is it clear to you? Okay. Now I will just draw a simplification diagram. So let us say this is a mean line. Okay, this is a mean line. Okay. Let us say this is a vertical line. Now draw this vertical line. Okay. Draw this vertical line. Okay. Draw this vertical line. Okay. Now this is a mean line, vertical line. So let us say this is the center line now. Okay. So let me draw the center line. This is the center line. Okay. So now I've got this. Okay. So vertical line, mean line, and the center line. Okay. Now you can see that this is the center line. Okay. Vertical line. So if I join this, okay, I will get this angle. So which is this angle? This angle is alpha. This angle is also alpha, right? Now tell me, what is this vertical distance? What is this vertical distance? Anybody? This vertical
X.
distance is nothing but the x. And what is this actual distance? What is this actual distance? Y. Now, basically, guys, have you understand why I have drawn this small free body diagram or a triangular diagram? हे कशासाठी केले? Have you understand this?
Yes.
This why? Because you have to calculate this
Get
y,
pi.
na? Yeah, you have to calculate this y and x relation. Otherwise, how will you calculate kinetic energy? So from this, cos alpha is equal to how much? Adjacent side
X
upon hypotenuse. So x upon y. Now guys, you know x means what? You have given, let us say तुम्हाला माहिती आहे की you have given, let us say, a 10-meter vertical displacement in a downward direction. Let us say you know x is equal to 10 meter, you have given, but you don't know the y exactly, what is y. So you can get y from this relation. So what is y? What is y? X upon cos alpha. Okay. So this is the relation which I have needed and I have got. I hope it is clear to you. Now message me, have you understand this or not? If you have understand this particularly diagram which I have drawn, this particular diagram which I have drawn, then we are happy. Okay. So in this way, you have to use a logic, that is a mechanics logic or any logic, any theory which you have studied in the last 2 to 3 years, and you have to solve this type of problems. Okay. So y is equal to x upon cos alpha. I have got a relation. Okay. And this is a figure. I hope you understand this. So I'll rub out this all, and now we'll start. Okay. So from this I have got this relation, y dot is equal to x dot upon cos alpha. Okay. Now kinetic energy. Okay. Now kinetic energy of the system is what? Kinetic energy of the system is equal to kinetic energy of fluid is equal to 1 of y dot square. Now you know that y is the actual displacement. Na? So you cannot take 1 of mx dot square, right? Because what is the actual displacement in that? Okay, so that you have to consider, right? So y is nothing but the actual displacement. So kinetic energy of a fluid is nothing but a 1 of my dot square. Okay. So now rho is the density of the fluid, cross sectional area. Mass of the fluid is what? Rho A into L. This will not change. Rho into volume, that is equal to rho into area into length. Okay. So this will not change. This will remain same. So now kinetic energy is what? 1 of, what is the kinetic energy? Kinetic energy is equal to 1 of m is what? Rho A into L. What is y? Y dot x dot upon cos alpha bracket square. Okay. So you have got this relation. I hope you have understand this. So I got this relation. Kinetic energy equal to 1 of rho L x dot square upon cos square alpha. Now you can see I have converted this y into the x because I have to use one term. Okay. Next. Now potential energy. Anybody. Now potential energy means what? First of all, how will you find out the potential energy? Potential energy of a system is equal to potential energy of a displaced fluid. Potential energy of a displaced fluid. Okay. So if potential energy of a displaced fluid, if you have to calculate, how will you calculate? Same, by the same formula. Okay. How will you calculate? Now you can see mass of the, first of all, mass of the displaced fluid. First of all, you have to find out mass of the displaced fluid. Okay. So mass of the displaced fluid is equal to what? M is equal to rho A into Y. Is it clear? This is for a one tube. Huh? This I am talking for a one tube. For both tube it will become 2y. Okay. So mass of the displaced fluid. Y is the actual displacement, na guys. So mass of the displaced fluid M is equal to rho A into Y. Okay. And this rho A into Y, rho A into Y is the liquid mass, is the liquid mass which is raised, very very important, which is raised by dash distance. Tell me, what is that distance? Rho A by Y. This is the mass of the liquid which is raised. Means what? Which is raised or displaced by what distance? It is displaced by
X.
x. Yeah, x distance. So I hope it is clear to you. Okay. So those who are not clear, you can see here. Okay. You can see at this position. Mass of the displaced fluid is equal to rho A into Y, and it is raised from this point. It is raised from this point to this point by x, and its potential energy will act at a distance x by 2, that is equal to at the rate Cg. Okay. So now you can solve this problem very easily. So how you can solve this problem? So potential energy is equal to mgh plus mgh for second tube, for one tube. So let me solve this. So it is equal to rho ay, okay, rho ay into g into x by 2 plus rho ay into g into x by 2. This is another rule. So this will become what? Rho ay into g into x, because what, 1 by 2 is 1. Okay. Is it clear, all of you? Okay. So now you know that rho ay, what is y? Guys, what is y? X upon cos alpha. Okay. into G into X. Okay, so now this X will become X square. Okay, so this is nothing but the potential energy you are getting, equation number 2. So in this way, I have calculated the potential energy and I have calculated a kinetic energy. Okay, is it clear, all of you? Now, once you have calculated this, what is the next step? What is the next step? Total energy of a system is equal to constant. Now, what is kinetic energy? 1 of rho A into L x dot square upon cos square alpha, plus rho A into G x square upon cos alpha is equal to C. So this is potential energy and this is kinetic energy which I have calculated, right? So what is the next step? Anybody? What is the next step? Differentiate. So by differentiating, we will see what is the answer, what answer we are getting. Okay, so differentiate this rho A, differentiate with respect to time, rho AL, 1 half rho AL, okay, into 1 by cos square alpha, that will remain constant, into 2x dot into x double dot, plus rho AG upon cos alpha into 2x into x dot is equal to 0. So now tell me what will get cancelled here. This 2 will get cancelled, this 2 will get cancelled. Okay, then this rho A will get cancelled, this rho A will get cancelled. Then cos square alpha and cos alpha will get cancelled, so 1 cos alpha will remain. So here you will get Lx double dot upon cos alpha, sorry, upon cos alpha, na? मैं correct कर दूँ. Yeah, Lx dot upon cos alpha plus 2gx plus 2gx is equal to 0. Is it clear? Is it clear what you are getting finally? 2gx.
Yes, sir.
Yeah, okay. Now what is the next step? Anybody? What is the next step? Next step is what? X double dot plus, so divide this whole term, L and cos alpha, divide this whole term by this 2g. What are you getting? So 2g cos alpha, 2g cos alpha upon L into x is equal to 0. Now compare this with the standard equation of harmonic motion. Now compare this equation with the standard equation of harmonic motion. What you will get? Okay, so what you will get? Okay, rub this out all. Okay, so these are all, and let me see what I will get. What is standard equation? X double dot plus omega n square x plus is equal to 0. So from this I am getting omega n is equal to square root of 2g cos alpha upon L heading to seconds. Okay, so Fn is equal to 1 upon 2 pi square root of 2g cos alpha upon L hertz. Okay, so the problem is over. Now tell me, have you understand this both the problems or not? I want an answer from your side. Is it clear? So if there any doubt from your side, you can ask me. Else we can move on to the next part or the next problem. Okay. I hope it is clear to all of you. Okay. So this is one more problem which I'll give you for the homework, or maybe we solve in the next lecture. There are a lot of problems actually. Number of problems we will solve. Okay. So this is one more problem we will solve and then we will stop. Okay. Within a 10 to 15 minutes we are able to solve this problem. So this is again one more problem. Again here you have to apply the concept of you can say a simple pendulum only. Okay, so determine the natural frequency of oscillations of a half solid cylinder of a mass m and radius r when it is displaced from the slightly from the mean position. Okay, slightly from the mean position means what? What they have given you? They have given you this half solid cylinder. Okay, they have given you this a half solid cylinder, right? and you can say this is the O position. And they are saying that determine the natural frequency of oscillation of a half solid cylinder of a mass n and radius r when it is displaced slightly from the mean position. Means what? It is displaced from this mean position, that is a point O, or you can say the equilibrium position. Okay, so let me call this as a point P. Let me call this as a point P. Okay, so let us say this is a grounded one. Okay, now you know that this is a for half cylinder G, this radius is R. Let us say R is the radius. Now you know that this distance basically they will not give in your problem. Okay, this distance they will not give in your problem. This distance they will not give, will be not given in problem. Now you know that from point O up to the G, the center of gravity lies at 4r upon 3 pi. 4r upon 3 pi. We know na this is for a half solid cylinder. What is the distance from O to G? 4r upon 3 pi. So what will be this distance, downward distance from G to P? This total distance is r. So this G to P distance will be r minus 4r upon 3 pi. So this analysis you have to understand by your own. I hope guys it is clear to you. Okay. So this is will not given in your problem. So this is will not given in your problem. So you have to understand that from O to G it is 4r by 3, that is the standard. So this will be r minus 4r upon 3 pi. Okay. So this you have to understand. Now let us say that this cylinder, now let us say that you are giving a small angular displacement to this cylinder. Now small angular displacement means what? Let us say you are giving a small angular displacement theta. Means what? Let me say that it is displaced at this position like this. Okay, it is displaced at this position. What is this? What is this? What is the displacement? This will be, let us say, theta. Okay. Now if this is the theta, now in this case, let us say that this point P will move towards this point P dash. Okay, and this G dash, I will draw again. Okay, you can see that this is moved to the P dash. Okay, हा तुमचा P dash ला जाईल, and I will take another color. Now this G will move to where? G will move to G dash. And what is this angle? This angle is theta. Okay, now we can see what is happening here. Okay, now anybody tell me what will be this distance? What will be this distance? Wait, I will draw a diagram and then I will explain you. So that will make you easy. I will draw a bigger diagram for you. So that will make easy for you to understand. So basically, okay. So okay. So say, let us say this is a point O. Let us say this is a point P. Okay. And now let us say it is displaced from its original position. See, basically this diagram is very, very important. Let us say this point is G. Okay. So G will move to G dash. P will move to P dash. Okay. And this angle is what? Theta. Because I am saying that I have given a small angular displacement about this point P. Okay. So basically, guys, you have to understand that you have to find first of all IP. Okay. Because this particular half solid cylinder is displaced at the point P. It is not displaced at the point O. Right. So you have to find out the IP, but that is a later part. We'll understand first of all small analysis. So now to understand this small analysis, now let me explain you that this distance. What is this distance? This distance is what? 4r upon 3 pi. So can anybody tell me what will be this distance? Yeah, I want this distance now. Yeah, this distance. Anybody? Because this distance will be what? This distance will be h, right? Now this distance will be h. Again, now this becomes a problem of a simple pendulum. This becomes a problem of a simple pendulum. See, I will draw. If you want, I will draw this here again. For a simplification, I will draw this here. See, once you understand the diagram now, everything is easy. G and G dash, O dash. Okay, I will take a change of color pen. Okay, this is theta. Okay, so now you know that this is H. This is H. What is this? Anybody? This is also theta.
3 pi minus
Yeah. This is what, first of all, understand this distance 4r upon 3 pi. So what is this distance? Total this distance 4r
4
upon
r
3 pi
upon 3 pi cos theta.
cos theta. Yes, cos theta. This is what you have to understand. 4r upon 3 pi sin theta. So what is h? H is equal to 4r upon 3 pi 1 minus cos theta. Okay. So this is the analysis what I was expecting from your side. So this is I am getting for. So this h, this is nothing but a 4r upon 3 pi cos theta, and h is equal to 4r upon 3 pi 4r upon 3 pi 1 minus cos theta. Okay, is it clear? So this is the analysis which will happen after you have given a displacement. So please message me. Have you understand this analysis? How I got this 4r upon 3 pi cos theta, how I got this h. And now you can find out potential energy is mgh and kinetic energy is 1 of mx dot square, or sorry, 1 of I into theta dot square. Okay. So this is what. So you can see this is a diagram which I have drawn here. Okay, for simplification. So this distance is 4r upon 3 pi. So h is nothing but a 4r upon 3 pi, 4r upon 3 pi cos theta. Okay. So basically what is happening, this particular point P is moving to this point, let us say P dash, by small angle theta, and then what is happening that we have analyzed. Now we have to calculate. Now what will happen? This will oscillate like a simple pendulum, but you can call this as a compound pendulum. Why you can call it a compound pendulum? For simple pendulum, we are neglecting the mass. But here, this particular solid cylinder will have some mass, and it will oscillate about this point O and P. So P is the point where it is oscillating, right? So this is how we have to do the analysis. Okay. So chalo. So this is the analysis what we have done. So a small diagram which I have already explained you. So O to G, G to G dash, theta, 4r by 3 pi sin theta, 4r by 3 pi cos theta, and h is equal to 4r by 3 pi into 1 minus cos theta. Okay. So this is the this diagram. I have enlarged this diagram basically. This diagram I have enlarged. Okay, for analysis. Now we'll solve this problem very easily. So what is kinetic energy of a solid cylinder? 1 of Ip into theta dot square. Okay, Ip, because at this point we have to find out, see, at this P point, it is changing from P to P dash. Na? So first of all I have to find out the Ip. Okay, so that is why kinetic energy is nothing but, kinetic energy of solid cylinder is nothing but 1 of Ip into theta dot square. And what is potential energy? Mgh. And what is h? Mg 4r 3 pi upon 1 minus cos theta. Okay, is it clear? Okay, then what is the next step? Total energy is equal to constant. It is very easy. 1 of ip theta dot square plus mg 4r 3 pi 1 minus cos theta is equal to c. Okay, so now we solve this, differentiating with respect to time. So what you are getting basically 1 of ip into theta dot square plus mg 4r upon 3 pi minus mg 4r upon 3 pi cos theta is equal to 0. Now you differentiate, the derivative with respect to time will become 0, and this will become minus sin theta into theta dot, and this is the constant term. Okay, so same process. I haven't changed the logic. Okay, so differentiating with respect to time, you are getting ip theta dot plus 4 mgr 3 pi theta is equal to 0. Okay, right? So compare this with the standard equation, theta double dot plus omega n square theta is equal to 0. So comparing with the simple harmonic motion, what you are getting? Theta double dot plus 4 mgr 3 pi p theta is equal to 0. So omega n is equal to 4 mgr 3 pi ip upon ip radian per seconds. Now guys, it is very important to understand this is not the end of the answer. So let us say if the problem is of 10 marks, okay, and you have solved a problem like omega n is equal to square root of 4 mgr 3 pi upon ip, maybe you will get 7 or 6 marks, maybe 6 marks or 7 marks. Okay, but this is not a complete answer, because first of all you have to keep calculate ip. But his answer is correct, only now here I have to calculate the ip. But how will you calculate ip? Anybody? How will you calculate ip for this particular figure? Now you know what is io. Yes, anybody, what is io? Io is nothing but the m r square by 2 for us, for this particular at point o. Okay, now you know that io. Yes, what is io? IO is nothing but the IG plus M into OG square,
M.
right? M into OG square. So first of all, you know IO, then you have to find out the IG, okay? And then you have to find out the IP. So what is IP now? What is IP? How will you find out IP? Anybody? How will you find
I
IP?
not
IP
mind.
is equal to IG square, sorry, IG plus M into GP square, right? GP square means what? Distance from this to this. Means you have to first of all find out IG. You know IO. IO is nothing but a MR square by 2. If you consider it as a circle, okay? Then you have to find out the IG. If you find out IG, you will get IP. So parallel axis guys theorem you have to apply. So I leave it to your side. So you can do the homework and you can solve this. It is very easy, not so difficult. You can see IO is equal to MR square by 2. IO is equal to IG plus M into OG square. So Ig is equal to IO minus M into what is OG? OG is nothing but a 4 upon 3 pi square. So solve this, you will get MR square Ig. You will get the equation of Ig. Now you know IP. IP is equal to Ig plus M into GP square. So put Ig here, and you know what is GP. GP is nothing but the R minus 4R upon 3 pi. And then solve this equation. It is very easy. Solve this equation, and finally after solving, you are getting this IP is equal to MR square 9 pi minus 16 upon 6 pi. So how will you solve this equation? It's not so difficult. IP is equal to Ig plus M into GP square. Ig is MR square by 2 minus 16 MR square by 9 pi square. GP is R minus 4R upon 3 pi. Then solve this bracket. R minus 4R by 3 pi means what? A square minus B square. A minus B bracket square. So A square minus 2AB plus B square. Right? So solve this bracket. Solve this bracket. You will get some term and finally you will get IP. Okay. And now you can put this IP here. So omega is equal to 1 upon 2 pi 4 mgr 3r pi upon IP. Put IP here and finally you will get omega n. Finally you will get omega n. That is Fn. Sorry. Now tell me, have you